So in this last piece, on the top of page 14, what if you do not have a domain restriction? Meaning our domain is from negative infinity to positive infinity. How do we determine if we have an absolute extrema? And if we do, how do we find it? So first of all, we're going to take a look at even degree functions. So if we have an even degree function, okay, what we're looking at is, let's take something like this, and the most common one we would know would be a quadratic, meaning a parabola. So this isn't necessarily a parabola, but it's an even degree. So when we say the limit as x approaches negative infinity of our function, our y values are heading towards positive infinity. Here, when we're looking at the limit as x approaches positive infinity, my graph is still increasing here. Okay, so this is what we're looking at. So how do we determine what our absolute max or absolute min is? We need to take a look at the degree. So if the function is continuous everywhere, then your function f will have an absolute minimum, but no absolute max. And then in this case, this is an even degree with a positive leading coefficient. So then here, this is also an even degree because the scenario is the same. However, what happens is that you have an even degree with a negative leading coefficient, which basically means your function or your graph turns upside down. So in this case, you will have an absolute max, but no absolute min. Okay? So you need to look at the degree. Now, what if you have an odd degree, meaning a cubic or something to the 5th power? So you need to think about the polynomials and behavior. And you did this in Algebra 2, so this is something that you need to remember. So what we're looking at here is, let's say we had a cubic function, x to the 3rd power. We know that the graph goes like this. Okay? But if it's negative x cubed, the graph is going to flip over. Okay, so you need to think about what's happening here. So in this case, if you have the limit as x is approaching negative infinity, the y values are going down, meaning heading towards negative infinity, and then as x is approaching positive infinity, your y values are also becoming more positive. There is no place where you will have an absolute max or an absolute min. Okay, so neither an absolute max nor an absolute min, and this is on this interval. So in this case, you would need to look at the end behavior. So you need to look at the degree of the function and the leading coefficient. So this is where you have a positive leading coefficient, but an odd degree. Here you have a negative leading coefficient and an odd degree. So in this case, everything just flips over. So as x is approaching negative infinity, your y values are increasing without bound. As x is approaching positive infinity, your y values are decreasing without bound. Therefore, there will be no absolute max or min. You could have a relative, but we're talking about absolute max or absolute min on that interval. So it has neither.